cut you off there. Sorry for that, so that we can start the meeting. I think it's 3 p.m. now. So yeah, thank you very much everyone for joining us. We really appreciate it. We know that it's not always easy. These are busy days, and we host these meetings during the time when most people in the continent are busy. And elsewhere, it's early in the morning and people are waking up and, getting to start their day. But all the same, we thank you very much for making this effort to be with us. So today, let me introduce myself, I guess. I'm Farai Majandu, the president for OneQuantum Africa, which is a chapter of OneQuantum, the global quantum tech community that brings people from all walks of life who are interested and active in quantum tech together, so that we can build an industry that is fair, successful, and that supports each and every one of us. Today we are going to hear from Desalegn from Debre Marcos University in Ethiopia. You will talk to us about the generation and manipulation of photons from quantum photonic integrated circuits. We are going to learn why this is important for Africa. And you also look at how quantum technology can come out of the lab to the real world. What are the African perspectives that we need to get that happening? Desalegn is a lecturer and researcher and student assistant, and I'm going to talk more about him as we go. Let me just pay the bills and share a bit of what has been attributed to me by André and Denise at OneQuantum Africa when they were asking me about why quantum is important in Africa. So I say to them, quantum physics governs the behavior of matter at the atomic scale. And because now we have understood much more about it and we keep on understanding more about it, we have been able to harness this behavior to bring new capabilities that are opening up the field of technology and enabling the creation of new businesses that can help to solve many of today's global challenges. That could be in quantum computing, it could be in sensing and metrology, it could be in simulation, it could be in quantum chemistry, molecular biology, and many other respects. So after delivering groundbreaking technologies in terms of bringing us transistors, solid state lasers, and GPS, which is the unsung hero of these technologies, which enables us to communicate and navigate, we are now entering what is being touted as the second quantum revolution. And Africa's competitive advantage, as we all know, is its talented young population. And I think according to recent statistics from the United Nations, Africa has got about 60 to 65% of its population as youths. So for that reason, Africa cannot simply afford to be left out of the quantum revolution, because this revolution will sit at the core of building new enterprises, future careers, and workforces. And this is the reason why we need to come together and just build strong local communities where we learn about quantum technologies, we pay attention to what is happening, we learn about how things are happening across the world, and we adapt those to our own circumstances, and we figure out appropriate uses for this technology in Africa. In general, let me share a bit about OneQuantum at a high level. Our vision is to build a supportive and authentic community platform for anyone interested and active in quantum tech because of its far-reaching impact. We want members to have access to education and skills, as well as to build local communities that are very strong in quantum and connect these local communities to global opportunities and also the global community. And in order to achieve that, I think we have put in place some very nice programs which we can take advantage of, or which anyone who is part of this community can take advantage of. We have got a mentoring. We've got mentoring happening for women in quantum chapter, which some of you may know, recently concluded a very successful summit. And we have partnered with Keysight Technologies to make this free. And we are going to share details as we go about how this can happen. You can also visit our website at www.onequantum.org to learn more about this, this program. We are also working to give stipends to students in Africa to enable them to sometimes have data to come and join meetings like these ones and come online to learn about quantum. We want to support those who are doing postdocs to, as they learn, so that they can, take practical steps to build a strong foundation for a career in quantum tech. I'm going to talk briefly. I'm going to talk soon on another summit and career fair. And I think I've already mentioned that you can visit our website and check out a lot of the other things that we have put in place, including the content, the education, the careers, and the projects that we are thinking of and that we are working on. Right, these are the links. It's a link fest here. You can follow these links to learn more about our efforts. You can connect with me at farai@strapadas.com, and some of you already know my email. I share it generously in the newsletters on various channels. Really welcome the new quantum chapter from Nepal, and we are going to share details soon so that you guys can also join their meetings and support their growth as well. We also are going to you can share this link first. You can share this link first as well with other people. Apologies there. When you are babysitting at home, it's not easy. All the same, let's take it forward. So let me share more about the summit. So we've got a summit that is coming on the 12th to the 14th of May, which is our first African summit, or rather first Quantum in Africa summit for us. And we've got a lot of interesting things lined up, including learning sessions that also include keynotes. It also includes some talks that are very important and relevant to the continent, and it also brings together people on panels and discuss some very important aspects, especially about how we can fund quantum tech in Africa and how we can make quantum grow in the continent. So we look forward to having all of you there, and we are going to share more details. I think we've already shared details via the newsletter early this morning. We are going to keep on sharing details as they emerge. You can visit the link that I'm going to share later on in the chat to sign up. You can invite other people in the continent. I think it's a good opportunity to showcase quantum in the continent. Not many people in the continent know about quantum tech, and we want to show them that quantum is coming, and it is coming to Africa as well, and Africa can contribute and participate. And we also want to showcase the things that are happening in Africa in quantum. So we are going to be sharing details as we go. You are also free to reach out to me with any ideas, and if you want to suggest speakers, you want to present, you can always share your goals with me, and we can figure out how to make that happen. So you can connect with me on the various social media channels, on Twitter, LinkedIn, Facebook, on GitHub for those that are already there. I've got a website also on GitHub, and let's keep the conversation going and let's connect. Let me talk about today's presenter, Desaline Kasao Belete, an assistant lecturer in the School of Electrical and Computer Engineering, also a researcher in quantum integrated circuits at Debre Marcos University, Ethiopia, and a student assistant in quantum computing at the coding school. For some of you are already part of the program at the coding school, and you know how amazing that is. It is a very good first foundation for quantum. He has a bachelor's degree focused on electrical and electronics communication engineering from Wolo University in Ethiopia. Desaline is going to talk to us about his work in generation and manipulation of photons from quantum photonic integrated circuits, and also put this in context for us in terms of where this can be applied and why these guys are going through the pains of figuring out this technology. If you were there early on, he was taking me through why it is important to make sure that you can interface photonic circuits with optical circuits. I think it was electronic circuits with optical circuits. So I think this is something very important for quantum communications, and as we envisage the coming through of the quantum internet or the quantum network. So this will be a very interesting discussion, and I look forward to hear from Desaline about the brilliant work that these guys are working on. Let me also introduce our next speaker. So next week we are going to hear from Amiri Karamlu. He's a researcher at the Engineering Quantum Systems Division at MIT. So it's a department at MIT. And he's going to talk to us about quantum simulation using superconducting quantum processors. So that's a very important presentation from an accomplished researcher who's based at MIT. I think Professor William Oliver. Some of you may know him. He's quite an accomplished professor in the field and also a director at this at this school of engineering quantum systems at MIT. So yeah, I think I've said enough about what we need to know ahead of time, and I'll give up the floor to Disalin. So thanks, Disalin, for doing this with us.
All right.
Looking forward to hear from you. So yeah, I'm going to stop sharing my screen, and you can start sharing yours as well and take this off. Take this away.
Okay. I guess I can able to share.
Yeah, I think it's coming through.
All right.
Now we've got a full screen. Yeah, thank you. Can take it out.
All right. Thank you all for taking your time to hear about my work, and thank you, Farah, for this coordination to make African as an influential continent by working together. I'm Desalegn Kasao from Ethiopia. As Farah said, I do have bachelor degree in electrical and computer engineering, focus on electronics and computer engineering. So my research on optical integrated circuit is that I guess, yeah. My research on quantum integrated circuit is just to come up with the real application of quantum optics, quantum communication. So here I would like to say something about my work as by outlining it as here the context, what will be the behind the optical sense, as well as how can we able to generate photon from quantum IC, and then we'll see the overall system. So here, as you see here, this is the beauty of quantum internet that many scientists and engineers are working with to to interconnect the world within quantum internet, which is pretty cool and super fast. So here, how can the science behind this one is how can we able to accomplish this quantum internet? So here, many quantum computing scientists work on cryptography, and also how can they able to secure their quantum bits at small level. As you know, the quantum mechanics come in a research in the principle of what will be the science behind when particles are at small level. So here, I just try to visualize this one on the perspective of engineering and the that of the computer science part. So here, come up with the optical science. This is the science of using light as a communication medium. But even though we do have many source of light in the world, but it need some sort of guiding principle in order for the light to be modulated, and which act as a channel for communication. So this is the beauty of nature, which is which indicates that light if it is properly guided, can able to transmit data even in terahertz. So here, the main task here is that how can we able to generate single photon? So come up with that. The main thing to come up quantum technology out from the lab to the real world is just how can we able to transmit a quantum bit, or we may say the qubit. So here, generating and manipulation of quantum optical state on a chip, which enable us quantum technology out from the lab. We know that many physical systems like trap ion, semiconductor circuits, and photonics are exploited for quantum tech. But here, the photon, which is the quantum of light, play a vital role in order to come up quantum tech to the real world. Why this photon or the quantum of light play essential role? This is the beauty of photonics in quantum communication. So here we know that transmitting qubit by encoding in a photon is easy by means of free space optical communication, or we may use optical fiber. So the thing is that if photons are essential in order to transmit qubit or quantum bit, how can we able to generate this photon? This is the essential work that we are looking to know. So we came up with the concept of nonlinear parametric process for generating a fundamental state of light or photon. So here we look at on the second order nonlinearity. That is the response of certain parametric process. The second response will monopolize the third response. This is the science behind nonlinear optics. So we can able to generate two daughter photon from a single photon by using laser pumping. So here the main thing is that we can able to generate two daughters photon from one by the process known as spontaneous parameter down conversion. This one is nothing but the classical equivalent of nonlinear optics operation, that is difference frequency generation in classical approach. So this one starts from the classical approach of difference frequency generation and come up to the quantum approach, that is the spontaneous parametric down conversion. So here is the thing, the main operation. When we do have nonlinear medium, and when we pump this nonlinear medium by pump laser, it will generate a photon pair. That is, we say, two daughter photon. So come up with our overall research. Our main task is just how can we able to generate a photon? How can we able to manipulate this photon? And how can we able to detect this photon on a single compound semiconductor device known as gallium arsenide wafer chip? So we choose this gallium arsenide because of it can operate on higher frequency, and also the wafer cells are insensitive to temperature. So we don't need any complex electrical cooling circuit. So many researchers work on silicon semiconductor chip, but on silicon you need to have to design some sort of cooling stuff. So to overcome this problem, we choose gallium arsenide wafer, and we just try to generate this photon and manipulate and detect this single photon on this wafer chip. So this is our main task, and the 3D print of our work. This one is just, we are mainly focusing to come up with this one. And if this device is printed on industry, we can come up easily the quantum tech to real world. So here, as you see here, let me use the, here is the pointer. Let me use this pointer. As you see here, this is the wafer that is made of gallium arsenide, which is doping of gallium with arsenic, P and N type. So that is from the perspective of semiconductor physics. So once we get this wafer, which is insensitive for temperature, what we are working on is that we come up with science of optics. This is laser. So if we do have this laser, we do have some sort of laser tuning in order to control how much power we need from the laser. So we do have some sort of controlling stuff. And then this is the device on the wafer. This is another device, the interferometer. When the laser hit this one, we may think this one as non-parametric device. What will happen? The single photon will be the single photon from this laser will generate two daughter on difference entanglement. So here we model this entangled Qv test, which is generated when a laser is pumped on this device. So we do have, we think this two daughter cell as signal and idler. This one come from, if we talk on the advanced level, this one came from the non-parametric process. So here the science is that we do have some device. This device do have valence and conduction band. So if we approach this, if we imping photon on this device, some sort of emission will be here. So this thing that we get from this one on the spontaneous down conversion is that ideal, which is occurred from, we may say, it's a kind of ideal operation. It may be from the fluctuation of the air. So here the signal, when it is polarized horizontally, and the ideal is polarized vertically. And also what will happen when the signal is polarized vertically, and what will happen when the ideal is polarized horizontally. So here we do have a kind of single photon detection stuff here on the receiver side. So this one, as you see on this side, is just kind of transmitter, and this one as kind of receiver. So on this single wafer, if we can able to design a transceiver, which is transmitter plus that of receiver, why not we can able to access this quantum tech into real world. So here on this one, you may have some kind of cutting stuff. As you know, we do have some quantum gate. So the quantum gate, the optical science, all these things will be on this single chip. So if we can able to manufacture this chip, why not quantum will out from the lab? So this is kind of stuff that we are concentratedly working on. These are some of the reference. Thank you all for your time.
Okay, thank you, Desalim. Thank you very much for your presentation and for sharing the work that you guys are doing. So would you mind perhaps recapturing what has been the motivation behind this work? Or what makes it very interesting to you guys to get on it? What specific problem? Perhaps there could be a story behind it so that we just put it in context.
Yeah, here the problem, I may start. The research is just kind of come up on integrating. We know that the computing researcher said that the engineers will do printed version of the device. So we just motivated on that. If we do have certain type of quantum gate, which can alter, it may shift or it may transform from one orientation to the other one. And also, they know that it's difficult to transfer a quantum bit. Still now, many researchers on the computing stuff are working on Qiskit. It's just, we may say, virtual thing. They just they generate a random thing and they try to analyze some certain work. But here we motivated, why not this kind of stuff come upon the engineering perspective, and we just interconnect the people from the electronics and the optical section as well as the gate part. So all these things will be interconnected on a single chip. That is where just try to accomplish this one. If it is so fine, we just plan to print on the 3D. Hopefully, I will. This is the ongoing research. Maybe if we can able to accomplish the 3D printing, I will share that one as well. For now, I think this will be helpful.
Okay, sounds good. Thank you very much for that. So while I'm waiting for questions from the floor, I was going to ask about what has been any challenges that you have faced and how are you overcoming them on this journey to realize this device?
Yeah, the challenge thing on this overall integration is that the software part. You know, coming up on all this thing is so difficult. The laser science by itself needs kind of independent research. The gate part as well needs independent research, and also the wafer part, it needs kind of independent research. But we just try to overcome this one by using some photon design software. So it's just so helpful. And also the people that are participating on this one do have some difference background from electronics and from quantum. So the programming section and the engineering section, when it's integrate, help us to overcome this challenge. I may say it's not fully overcome. We're working on precision. If something is difficult, we're just using separate software to handle that one. But it's pretty cool. It's motivational and it's new. And also many fabric start application specific photonic chip production. So we're just reading some sort of product that are started there. I think it's pretty cool.
Sounds good. Really exciting work to see you guys working on the quantum engineering side of it. Really exciting to see that happening. Any questions from the floor? Yes, Abdul?
Yeah, hello, Brian. Can you hear me?
Yes, I can hear you, Abdul. You can go ahead. You can go ahead.
Oh, sure, thank you. Yeah. So I have basically two questions. The first is what is the what range of frequencies does this device would operate on? And also like can you sum up again like the material that are used in the device? I remember using gallium arsenide, right, as a wafer chip. Yeah, sure, exactly. Yeah, what about the receiver side? Is it the same thing, or are you using some kind of a mix up?
Yeah, on it's a single chip. The transmitter and the receivers are on the same chip. That is gallium arsenide wafer. So it's just a kind of transceiver, which include transmitter and receiver on a single chip. Come up with the frequency band. We're working on the ultraviolet part, mainly often the photonics, as you know from the spectrum perspective. The photonics band is just in terahertz operation. So you may say that within certain nanometric wavelengths and kind of terahertz frequency. More often, it's above 10 terahertz. We're working to accomplish this kind of device. I think, may I get, did I get your question, Abdul Malik?
Yeah, sure. Thank you. Because I was just thinking about like what triggered my question, because I was thinking about the pump pulse period of the from the pump
femto,
interferometer.
yeah, on the femto, yeah, it's good view, yeah. So
Yeah, thank you very much.
Yeah, it came from the particle quantum side. As you know, the light characteristics will govern by three side. The propagation side, which is governed by Maxwell, we may say electromagnetic wave side, and the quantum side. This is focused on electron hole recombination. And the third one, the geometrical optics side. So here we use the quantum side. So the quantum side mainly focus on the duality nature, wave particle duality nature. So you will focus on the photonics band. That is how a single photon will be generated. This single photon will be generated on the recombination of electron and hole from the device that we're using. The device do have its own concentration. So when some sort of electron and hole recombine from one place to the other, current side will inject, and this, as you know, this photon will emit. That is from quantized energy.
Okay, thank you very much for that detail on the theories of the device. I think really exciting. I hope that everybody is comfortable. If you've got any questions, feel free to come through and ask Desaline so that he can unpack the photonics, the device, or anything else that you want to know.
Yeah, please come up with a question.
So that I don't keep on asking alone. I've got a lot of questions for him. Anyway, while we're waiting for that, are you working with any collaborators across Africa or internationally on this work, or will you be open to collaborate with others if that can happen?
Yeah, we're open to collaborate with anyone. Currently, we do have a team of researchers from the staff. Some sort, we are all lecturer, and also we do have some professor in Europe that they are just give some sort of highlight. And we're just open to collaborate with anyone because this work needs collaboration.
Sounds good. So yeah, thank you very much. Anybody else who is here, or if you know somebody who is interested in quantum photonics, then come through and you can collaborate with Desalegn and team. So I think I'm going to go to the chats. I see something there. How did you first become interested in quantum, and do you have any advice for those just starting in quantum, especially perhaps in the field of quantum photonics?
Yeah, I think quantum computing may not need any sort of background, especially electrical or physics background. But the first thing for those who would like to proceed their career journey on photonics, quantum photonics, is just passion. If you do have a passion and you have some sort of analogy on the spectrum operation, it will be pretty cool. So many of the researchers currently that are held on worldwide are open. So I think if you do have passion, just try to know what is happening behind on semiconductor solid state physics, and then the computing part. Two things here may exist: the computing and the engineering part. Those who would like to approach toward the quantum hardware, they need to know some sort of how light will operate, and also how can we able to generate light from electronic device. They should know that one. Those who would like to continue on the theoretical perspective of quantum computing, they should know some sort of programming language, especially if you have some know-how on Python, or if you do have passion, you can learn from GitHub. So you should select your path. Either you would like to approach toward the computing part, or would you like to proceed to the engineering part? My advice is this one.
Okay, that's really great. Would you mind to tell us more about your role as a student assistant at the coding school, and how did you end up doing that? How has that journey been, and what are the lessons from there, perhaps?
Yeah, the coding school, which is funded by IBM Quantum Computing, there is a free course that is Introduction to Quantum Computing. Moreover, it focuses on the computing side, and it does have some sort of I may say academic part. So there, my role was that there is office hour every Friday that is hosted by student assistants. That's just helping a student if they do have some question. They do have 3 sections: the lecture section, the lab section, and the assisting section. So we're on the 3rd section. The professor and the researcher from MIT will give the lecture, and also the PhD candidate from MIT as well give the lab section. And on the student assistance role, we mainly help those who have some difficulty to accomplish their homework. So mainly we'll help them if they do have confusion on the homework section, as well as if they do have some general question on if we will answer and will give advice for them. That is my role.
Okay, sounds good. Sounds good. I don't know if there are any questions for Desaline from the floor. What was I going to ask? Do we have a good enough representation at the coding school? Are you seeing a lot of students joining from Africa? What's your comment on that?
We do have, I think, especially from Nigeria, we do have many students. They do have a passion, but on the rest, there are some, but I may say we are few. So we should work, and also we should be active. If we are proactive on the online session, we'll get information and we'll be part of that.
So what is the state of quantum in Ethiopia? How are you guys mobilizing each other to get into quantum? And what do you think makes people in Nigeria passionate about quantum? What should we do to just excite people to take action?
I think the first thing that we should all do is that we should highlight quantum optics for high school students. If we give some course for high school student, maybe many passion will come up from that one. So we should work on the teenager part, especially on the high school part. If we do so, it may be pretty cool, I think. And then collaboration will come, and we'll have enough manpower. So we also plan to do this here in Ethiopia, especially in summer break.
Okay, I think we seem to have lost Desaline.
Introduction to quantum computing on.
Okay, I think we seem to have lost him there. But yeah, sounds good. Thank you very much, Stanley, for joining us today. And well, yes, we have you back. We have you back. You can unmute yourself and perhaps conclude on what you are saying. We still seem to have an issue with that connection. Okay. Stanley. Okay. Thank you very much. So Desaline, would you mind perhaps going through the conclusion again? I think we lost you at some point. You are on mute. You're on mute. Sorry.
All right. Thank you.
Yes, you can conclude. I didn't hear what you said at the end.
Yeah.
No, I think we've got a problem with this connection. So what we are going to do is we're going to hear from Stanley. If you are busy,
I was talking about we should run quantum computing.
Yes, you were saying.
Oh, all right.
Yes,
may I proceed?
Yes, you can proceed. Now we can hear you.
All right. So what I'm talking about is that we should all work on high school student. We should introduce quantum computing for high school student, especially in summer break. Here also we're working on adjusting some material and also working on a platform to do so. So it may be helpful for African to introduce quantum computing, especially for high school students. Maybe it will be, I guess it will be pretty cool.
Sounds good, sounds good. So you were talking about the path from lab to markets. How do you think you end up getting your product, if ever, perhaps your research to the market to make a device? How is that path like in Ethiopia or from Debre Marcos University, or how are you thinking of doing that? Do you have anything in place to commercialize your research, or there's a path for it? How are you looking at it?
Yeah, well, the focus here is that on PCB. We know that many of us are working on printed circuit board on the electronics level. We'll do some electronic circuit and you can able to print with 3D printer. But come up with the quantum part, it needs some precaution in order to produce this chip, because the doping concentration do have an effect on signal processing. So it needs some sort of curiosity. So we're also working to know what will happen if this is done on the industry. Whether it will be good or not, we're just trying to figure out it. But I guess it will be pretty cool because the device will be small in size. So even though it's difficult to fabricate, I think it will be achieved. Because here in Ethiopia as well, the government are focusing on artificial intelligence and smart tech like quantum. So it will be part of that. So I think it will be pretty cool on the side of the government as well.
Okay, so if I read you right, you are saying there is government support for it, and there are commercial partners you are likely to approach whom you think are going to help you to get the product to market.
Probably it's difficult to fabricate here in Ethiopia, but it may be on the prototype stage. So I guess it will be cool. Anyways, we'll share the update as well. But
sounds good. So the most difficult part is in fabricating the device.
Yeah.
What is it that we need that we don't have in Africa, just in case somebody can help?
I think we need photonics lab. If we do not have such modern lab, we can't able to accomplish this one. We may do on the simulation stage, but it may be difficult without the lab. So lab adjustment should be the essential.
Okay, I hear you. Thank you very much for that. Let me end this with, there's a question from the chat. This one is for all of us, it seems. What do you think the type of events, workshops, collaborations that each of us can organize in his country in order to push ahead the quantum design research in African universities? Okay. What do I think the type of events? Do I even have an idea? So anyway, we'll start with Desalegn. You are the one who is on the spotlight today. What type of events, workshops, collaborations should we organize in our countries to push quantum ahead in terms of design, research, yeah, along those lines?
I think this one is a pretty cool suggestion we may say. I think this will be very helpful. Maybe to do this, we should work on the sponsorship part. We can able to organize such type of symposium or workshop, but it needs some fund. So to get this funding, at first we should work more. We do have something that is visualized at least in the prototype stage. But if we can able to find out some external sponsor, it will be pretty cool. Even it will step up our OneQuantum Africa ahead, one step ahead. So I appreciate the view of Abdul Malik. So this should be, I think, a good proposal for us. We all should work on that.
Sounds good. Thank you very much. Stanley, if you are not busy and you can contribute, what can you say about that, and what type of events or what type of approach are you guys using in Bolivia that you think we can learn from as well?
Well, here in my country, hi everyone. First, hi. Well,
Hi.
here in my country, the first step that the research institutions like the university are taking first, I think is going by the side of first invest in artificial intelligence and later move in the quantum side, because as the background right now is very low in the sense of investing in research, but this way in which the people can get interested first in AI tech, I think that will move the interest from here to the quantum side, because the both sides are converging, right? In some way, I think in the coming years, these sides of the path will converge, and will be a very valuable tool for anyone who can use this text in his work. And one application that I see of this technology in general is around the optimization of electrical grids, because I am right now in the background of electrical engineer, power electrical engineer, and there are a lot of problems around optimizations, and technologies like quantum in general can get very benefited for this side of problems. And my interest in go by this side, how to apply this technology to the optimization side of electrical powers. But it's not just this. Another people that are also interested in this side, and as I mentioned before, I think that both sides in the side of AI and quantum will converge in the following years. Just I think we must take the first step, and the work that you're doing is great, because it shows the interest and the real application that the people in the world are taking. Thank you.
Thank you very much. Thank you very much, Stanley, for your contribution. I think we really appreciate it. Okay, sounds good. So, yes, Lorraine, what do you think has to be happening at university level to support the growth of quantum in Zimbabwe, in the continent of Africa, and elsewhere? What are you learning, and what do you think? I guess she may be busy. I know there are people who follow our meetings and they're at work, so that's okay. Jamie, what could be your proposal if you could say anything in the hope that you are not busy and you can come through?
Oh yeah, well, I mean, I think it's obviously Fry what you're doing with the One Africa conference. I think that's going to be a real catalyst, a real fire starter to a lot of this, and I think that some of these things can pay off, you know, even if it's like a year or two down the road. I just look at my own personal journey, and I've been big into the events and everything. And then that's going to lead to me, you know, going to grad school next year and doing the studying and the research and everything. But these type of events and getting everybody together, you know, it can lead to a collaboration. Or it's like, okay, I know that Disceline's working on optics, so it's like, okay, if you know, it's like, okay, maybe he's the person I need to turn to do this or that. So yeah, I mean, doing these events and everything, I think will be valuable to connect people, you know, even if it's not immediate, maybe a year or 2 or 3 down the road of, hey, you know, this is the researcher I want to talk to. And this is when I do down the road, because there's so much going on. And I think Desaline's point was good too, with the high school students and everything, just kind of getting an interest, and even if it's just getting it in the back of people's minds, because quantum's still starting out. So you know, Stanley talked about, you know, all the electrical engineering problems and everything. You know, it's hard for people to just say, okay, I'm into quantum computing, I'm into quantum information, that's my one thing. You know, a lot of times it's taking a problem in electrical engineering, it's taking a problem, you know, in an existent field right now, and then making quantum just a piece of that too. So, so yeah, I think obviously all the pieces are there to get things started, and I'm looking forward to what comes about as far as the conference coming up. And yeah, I mean, I guess that's what I'd have to say on that. And just that the events definitely are useful as far as just kind of setting some of those foundations and groundworks to get those collaborations going.
Thanks for that. Thanks for that. I really appreciate it. And I think makes a lot of sense and captures everything into perspective. I'm not sure if Lesedi usually follow these meetings while we're busy with something else, but in case you've got something to say, so that you won't accuse me of overlooking your presence, which I really value a lot. So
thanks a lot, Farai. Look, I mean, I can only really echo what's already been communicated. I think collaboration is key at this point, and I do feel that with our varied expertise, we can slot into the puzzle at different points, right? So, for example, I might be more helpful to Desaline on the commercialization side of things, whereas if I ever need to pursue optics, I'll know which researcher to hit up. So I do feel like the key point coming out of these discussions is the need for greater collaboration. And I think to that extent, we're very much appreciative of your efforts in putting together these events. We clearly need more of them in order to get the collaboration off the ground, like has been said.
Thank you very much, Lesedi, for that. And I hope to find a way that we can merge our community with the II community in Africa. And I think, like Stanley mentioned, it's going to lay a solid foundation for quantum across the board. And looking at Africa, from your last presentation, Lesedi, we are likely to see the optimization problems speed up of machine learning and AI algorithms, you know, taking up, and there should be a way
100%.
to link these communities. I don't know how we do it. I need your help, so let's do it.
Sure, no worries.
My pleasure. Thank you very much, guys. So anyway, we could go on and love these meetings. You know how it is. So I know that you guys are busy with other meetings, and I will understand if you don't join the cocktail. But for those who are free, I think Lorraine shared the link for a cocktail. Let me know if you can join so that we keep this conversation going. And thank you very much. We will be sharing more details about the summit as we go. Yes, the summit is finally happening in Africa, and we're so excited about it, and we hope that it will be great, and you guys are going to make it great too. So yeah, I have no doubt that we are going to pull that off together. If there's nothing else to share, thank you very much. Let's meet on the cocktail, and it's always a pleasure to have you. Thank you, Desaline. Really appreciate your time. I know you were 1 hour ahead and came earlier, and you know how it is, but we are always trailing.
Thank you all. Thank you all. I do have another duty. I will not be on the cocktail room. Apologize for that, but
No,
I appreciate for taking time to here my research. I appreciate it. Thank you all.
Appreciate it. I appreciate Stanley all the way from Latin America. Thank you very much. We really appreciate your presence. And, you know, we need all these perspectives to make quantum and to make ourselves as individuals successful after. We need to learn more from other people. So I really appreciate it. Thank you very much. And let's meet at the cocktail or on social media or and everywhere else where we connect. Thank you.
Okay, thank you.